In the last video, we took a pretty deep dive down into a relational database called AdventureWorks and looked at what it was constructed from and something about the relationships among the collection of tables there. And we also took a deep dive into a data warehouse database called AdventureWorks DW, and found that in many ways it was very similar to the relational database in that it was a collection of tables, but these tables were of two distinct types, dimension tables and fact tables. And so in constructing a database, a data warehouse database, it's obvious that we need to decide, how do we get dimension tables and fact tables? Where do they come from? How do we derive them? And it's not too difficult in concept, but in actuality it turns out to be not a trivial thing. First thing, let's take an example. Let's talk about, since a data warehouse purpose is to be able to answer various kinds of specific questions so that you can query it and get information out of it relatively easily. And let's take an example, say that maybe we're interested in what are my sales by date and product group. How does that give us some insight into what the dimension tables and the fact table might be that would answer that specific question? Well, it turns out that dimensions really are the thing that comes after the things that come after the byword. So in this particular case, the dimensions we would need is a date dimension and a product group dimension table, those two tables there. And these are also called slicers. Some people call them slicers, as in the phrase slice and dice. And this is the things you're going to pivot around on these dimensions. So you might start out by looking at, for a given range of dates, various product group sales within that, or you could take product group sales and break it down by dates within a product group, just whichever way you wanted to pivot that particular fact table. The fact table itself is usually the easiest thing to identify. In this case, it'll be sales. That's the thing that they're interested in. Typically, they're designed around business functions out of marketing, human resources, production. And these are the things that are going to contain the numerical values that we're going to be added, subtracting, or constructing averages, say, for example, in an analysis. These are the items that we're interested in. And what we would do is we would take these and we would construct a fact table and two dimension tables and then link them together into a star schema. We saw one in the finance area when we were looking at the AdventureWorks data warehouse in the previous video. You could imagine in your mind a pretty simple star schema with sales and a dimmed dimension table next to it, as well as a dimension product group table and adjacent to that. So it would be a fairly thin snowflake, but it would be a snowflake nonetheless. Or star rather, schema. And the star, there's another example in your book, figure 8.9 on page 353 of a star schema. So let's look at that one. And here, this is an example for an automobile insurance data warehouse. And the fact table that's going to be we're interested in is various kinds of claim information. So each row in this table would be this fact table would be about a specific claim. And each of these dimension tables, the four dimension tables, would be a individual item. Say each row would be a driver, in this case, information about the automobile that was being driven, information about the location, a specific location, information about time itself in here for these four dimensions. So we would be able to slice and dice along any one or combination of these four and to get information out about our particular claims or the information that we were interested or questions we're interested in answering. So when you're developing the dimensions and identifying the dimensions and identifying the fact tables, there are some specific key questions that you're going to have to ask yourself. First of all, what are the facts tables going to be? Where do I find the fact tables? Well, one of them is you can just simply list the fact tables you think might be relevant in your particular area based on your knowledge of the business. You could interview subject matter experts. You can look at reports in your organization and what questions are being addressed in those reports, what kind of questions get discussed in meetings, and just begin compiling a whole list of fact tables. Or you could go around and interview people and say, if you had a perfect database, what kinds of questions would you want to be answered answered by this particular database and literally record the questions and develop them something in this particular form. What are my sales by date and product group? And then go through them and say circle the nouns here and put boxes around the things that occur after the by word, and then that becomes a collection of your fact table and your dimension tables as well. Then you're going to have to identify if you have a list of fact tables, what the individual by questions are going to be as a set, because each fact table might have one or more dimension tables sort of attached to it, and you have to understand which of those, of all the candidate dimension tables you might have, are going to be the most relevant. And finally, for each fact table, this is a specific area that's very, very difficult. And if you don't get this one right, everything you've done before and after is going to be pretty much useless. You've got to determine what granularity level the questions are going to be for each fact table. By granularity, let me give you a specific example. Let's take a sales invoice, and let's imagine we have a sales invoice header table that describes header information, and maybe he even has a total amount in that table. And then underneath the header table, we have a relationship with individual line items that go into that particular for a particular sales invoice. And let's assume for the moment that we decide our fact table is going to be based on the header invoice, and we're going to be looking at total amounts of each sale and doing analyses based on that. If the first time somebody comes along and asks us questions where we need to understand and know the detail of the invoice items underneath each header, then we're pretty well toast in that we won't be able to answer that question. That means we don't have the granularity low enough to be able to answer the questions that need to be addressed. Now, you can get around that by just capturing the most detailed information, but if you wind up doing that, your data warehouse is going to be huge, and it's going to be not very efficient in querying, and it's going to be awkward to utilize in many cases. So you have to have a judgment here. You have to balance it, and it's not a perfect answer. In fact, likely over the course of time, the questions themselves will change, and the granularity level will change as well, and you'll have to go in, or your analyst will have to go in and make those changes in the data warehouse. So let's assume for the moment that we've identified all the fact tables we want and the corresponding dimension tables, and pretty well know the granularity level. How do we get a data warehouse? Well, the first thing we've got to do is we've got to take the database, that relational database that we have, and we've got to create the dimension tables themselves in the data warehouse. We've got to create the fact tables themselves in the data warehouse. And then for each fact table, we've got to actually link and make a relationship with the various dimension tables. And finally, we've got to go into the original database itself. In our particular case, it was AdventureWorks, and we've got to pull out all the relevant information from each table and put it in the right spot in the dimension and fact tables themselves. So we have to populate these tables. To do these 4 steps, even for a data warehouse of relatively small size, would take hundreds, if not thousands, of lines of SQL code to generate. It would take a long time. Lots of mistakes would be made. You have to debug, do it again and again, and it becomes a pretty onerous task to achieve. And so it was it's something that only large companies investing large sums of money actually were able to do because of that. Luckily, over the course of time, there have been tools developed that will allow us to go through and almost do these graphically and generate them graphically. It's not exactly fall off the log simple. There are a lot of steps involved, but it's a doable thing, shortens the time considerably. And it turns out that Microsoft's tool for doing this is called SQL Server Integration Services. With SQL Server Integration Services, you can set up the entire process of and manage the entire process of creating, populating, and doing ETLs to create your data warehouse as it evolves through time. So the next video, we're actually going to go through and set up a data warehouse and using SSIS.